Hello and welcome to Functional Skills Masterclass with me, Bill Haining. In this session we are going to look at averages and frequency tables. In this session you will learn about the different types of averages and their uses. Now, averages are used in everyday life to give information about a set of numerical data, give an overview of the values seen, and tell us the most common outcome. Range is a measure of the spread of the data, and we'll go through that as we go through the presentation. In this session, we're going to learn how to calculate the mean, the median, the mode. That's the three main types of averages. Then there's the range. We'll learn how to calculate that. And we'll finish off by finding out how to calculate the mean, median, and mode in frequency tables. Now let's deal with the mean. Let's take a typical question. And from that, we'll work out the mean. James is a spinner that has a section labelled 1 to 5. He spins the spinner 10 times, and here is his score. Okay, and the question asks, calculate the mean or the average. Now, you and I may know the most common one known as the average, but in mathematical terms, it's called the mean, but it's just the average. Okay, so what you do is you add up all these numbers, which comes to, in this case, 29. Okay, and you divide it by how many numbers there are, and there are 1, 2, 3, 5, 6, 7, 8, 9, 10 numbers, so you just divide it by 10. And you can see now that the average or the mean is 2.9. Now there is a temptation in maths that a lot of learners do, is they tend to try and round this number off. You never round the mean number off unless the question tells you to. So if the answer in this case is 2.9, you don't change it. So remember that little tip going forward. Let's try it for yourself. Here is a list of numbers. Okay, calculate the mean of these numbers. Pause the video and see how you do. So how did you do? If you got 5.3, well done. Lay and Roma roll a dice and add the scores together. Here's the results. Okay, calculate the mean. How did you do? Well, if you got 7, then you were correct. Now, if you get the wrong answer to any of these two or any of the questions, go back over it again and figure out where you went wrong, and then try again. Now let's deal with the median. James is a spinner, exact same question, but this time you're being asked to calculate the median. So what is the median? Well, to calculate the median, you have to rearrange all these numbers from left to right and from small to large, and it's the number bang in the middle. Now, if you look at these set of numbers, they're an even set of numbers, so you have two middle numbers. And rather than put two numbers down, what we do is we add these both together and divide it by 2. So therefore, the median is 3.5. That's the median. But if there is an odd number, if you work along these numbers and it becomes an odd number, then it's just the middle number. So the middle number is the median. You don't have to add anything to it. So let's see if you can have a go. Okay, here's a list of numbers. Calculate the median. Pause the video again and see how you do. So how did you do? Well, again, rearrange it left to right, small to large. And if you got 4.5, well done. Let's try another one. Same question again, but this time you're asked to calculate the median. Okay, pause the video. How did you do? All right, again, rearrange, and you can see in this case the answer is 7. So if you got 4.5 and 7, well done. Now let's look at the mode. Okay, now James is a spinner that has sections labelled 1 to 5. Exact same question again, but in this scenario they're asking you to work out the mode. Now the best way to remember the mode is by the first 2 letters in the mode. What that means is most often. So the mode is the number most often seen in a set of data. And to calculate this, just like before, you rearrange it from left to right, small to large, okay? And you can quickly see that there are more 4s in the data than any other number. So 4 is the mode. It's as simple as that, okay? But just take a note, if there are two numbers with an equal value, then there can be two or more modes. So if you look at this set of data, you can see here clearly there is 4 1s and 4 4s, and they're of equal value. So what you do then is you just record these, or you can be expressed as 1, 4. So there can be more than one mode. Just be aware of that. So now you try. Here's a list of numbers just like before. All right, let's calculate the mode. Pause the video. How did you do? All right, again, rearrange from left to right, small to large, and you can see the mode is 4. Again, same question again from Leah and Roma. Okay, work out the mode. Pause the video. How did you do? Again, rearrange from left to right, small to large, and you will see that the mode is 7. So you've got 4 and 7. Well done. Let's look at the range. Okay, exact same question again. You have to calculate the range. Okay, there's your set of data. So how do we calculate the range? Now the range is just the spread out of a data. So let's show you how to do that. And just like the other, the median and the mode, you just rearrange the data from left to right, small to large, and it's the distance between the largest and the smallest. So it's a distance between there. Okay, and if you take 5, take away 1, you can see then that the range is 4. So the distance between here and here is 4. And that's the range. Now let's have a look at, you have a go first here. Here's a list of numbers again. Calculate the range. All right, pause the video. How did you do? Again, just like before, left to right, small to large. And you can see here that the range is 10. Let's try a Leah and Roma question again. Okay, so you take that set of data and work out the range. Pause the video. How did you do? As before, left to right, and you can quickly see that the range is also 10. So if you get 10 for both, well done. Okay, and that is the range. When we would use them, when we would use these different types of averages in the range, well, they come up very often, and it's important you learn these because they will come up in your exam paper. So this really depends on the data that's presented to you and your audience, all right? But let's look at the data. It's mainly based on the data. When it comes to exams, you will be presented with a set of data, and you may be asked to select a suitable average. So let's look at the different averages compared to the data. Now, if the data is uniform and you don't want to include any extreme results, then use the mean. So if you look at this set of data here, it's fairly uniform. It doesn't vary too much. And you can see from the mean there, okay, a 3.7, it doesn't stray very far from this data. So when would you use that? Because the data is fairly uniform. Well, the mean is most used when measuring temperatures, heartbeats, goods produced, and student grade tests. So you can see there they don't fluctuate very much. So that would give you a decent average. So you would use the mean when your data is fairly uniform. Now, what if your data has extreme results like this? You can see it's mainly 4s, 5s, and 6s, but you've got this extreme results at the bottom, and that can drag your average down if you use the mean. All right, so if you see data with extreme results, either low results or very high results, it's not the normal, and you don't want to include them, then use the median, because the median excludes, you can see there the median in the middle, it excludes all the extreme results. So have a look at your data before you decide whether it's the mean or the median. Now these are the two main ones that they're asking for you to select in the exam, and it's all based on the data. So before you decide whether to use the mean or the median, look at the data. If it's uniform, use the mean. If there is extreme results there which you think can corrupt your mean, then use the median. The median can be used to find typical salaries or house prices that aren't affected by extreme values. Okay, so if you think of typical salaries, say the average salary in this country is £50,000. Well, if we use the median, then that excludes all the people on minimum wage and it excludes all the millionaires. So it's a number that's in the middle, which doesn't have your extreme results. It may not be a fair average, but that's how it's calculated, and that's how the house prices are calculated as well. Okay, so you can take these averages and manipulate it to suit your audience. Okay, mode, the number most often seen in a set of data. This is mainly used if you need to know popular sizes or colours for buying stock. Okay, so if you look at this set of data here, okay, and you're talking about the mode and you want to order stock, you can see your most popular size. This could be shoe sizes or dress sizes. So your most popular sizes are your 5 and your 6s and your 4s. So you would order more of these on the next order rather than get the ones in. Right, and the range is just spread out how the data is. All right, the lower the range, the more consistent the data. That is an important statement when it comes to your exams, because that's what they're asking you to explain. The lower the range, the more consistent the data, or the higher the range, the more erratic the data. And I'm going to give you a visual representation so you can see what I mean. You see that statement there, the lower the range, the more consistent the data. Now, this is an early question from when the reforms first come out, and I believe it's in one of the mock papers from City and Guilds. Okay, and the question asks, you and your friend have a broadband, different broadband companies, and you want to compare your broadband to your friend's broadband to see if you need to swap yours over and go to your friend's, or you want to keep yours. Okay, so this graph represents the broadband speeds over a number of weeks, and these two lines, the purple lines going across, represent the optimum bandwidth. Okay, so let's look at my broadband first, which is this one here, which has a range between 7 and 15. So you can see it goes up and down a bit. Okay, so that gives it a range of about 8. All right, but if you look at my friend's data, that goes from 13 up to 15. It only has a range of 2. All right, and not only that, visually you can see his data is more consistent over a period of time, and it's within the optimum bandwidth speed. Okay, so compared to my broadband, his is fantastic. He's not got many problems. Mine keeps dipping in and out. I'm losing service and all that sort of thing. I'm having problems with mine. All right, and the question asks, would you stay with your own broadband provider or would you go with your friends? And it's obviously you would swap over to your friends. Okay, because the lower the range, the more consistent the data. And you can see with mine there, the higher the range, the more erratic it is. And that's what that means. Okay, so if you can give that your answer in your exam, you'll get the full marks. Okay, the lower the range, the more consistent the data. Right, now let's look at frequency tables. This is an area and over the last couple of years that I have noticed within all the people who have passed or failed the exams. This is one area where they consistently failed. Even the people who passed this, their exams, never get this right 100%. They always make some sort of mistakes. And it's very straightforward. And you have to remember, it's high points. These are worth big points. So it's worth learning this so that you can help salvage some of the points in your exam paper. All right, let's look at calculating the mean from a frequency table using discrete data. All right, so what is discrete data? Well, examine the table below showing the merchandise and sales and answer the question that follows. Before we put the question up, if you look at this column here, this is known as the X column, right? And this column here is known as the F column. X is just your cost, your price, your number, whatever. But the F is the frequency column. That just means, frequency just means how many times something appears in a set of data. So for example, something have a value of £10 appears 25 times. So it just means the frequency, how many times something appears. Okay, so let's look at the question. Now, before we move on, this discrete data, the word discrete just means it's a solid number, right? You can take that number and you can multiply, add, subtract. It's a solid number, okay? Now the question asks, what is the mean amount spent on merchandising? And this is where most people make the mistake. What they do is they add up this column, they add up this column, divide this column by that column, and get the wrong answer, because that's not how you do it. Okay, and that's the most common mistake that people make. Okay, so let me show you how you do it properly. Okay, what you have to do is you take your X column and extend it out to your F column. So 10 times 25 is 250. £5 times 30 is 150. 25 times 40 is 1000. And 15 times 30 is 450. All right. And before you move on, you create a little fraction. So you underline that. And now you have to find the bottom half of the fraction. And that's where you add up the number of sales, or the F column. Okay. So you add up the F column, and you can see there 25, 30, 40, and 30. And that's you now created a little fraction. And if you remember in fractions, this line is called the dividing line. So you calculate the top part, calculate the bottom part, and then divide. So you can see there the top part equals 1850, the bottom part equals 125. Okay, you divide 1850 by 125, and that gives you an average of £14.80. And you can see it's within the realms of all these numbers, so it gives you a good average within these numbers. Okay, so the average, or the mean, is £14.80. Now that's discrete data. Remember, discrete just means a solid number. Don't get hung up on that. Okay, it just means a solid number. Now let's look at called continuous data. Finding the mean from a frequency table using continuous data. Okay, so have a look at this question. A photographer increases the price he charges to print photographs. He wants to know if this affects his sales. Last week, before the increase, the average number of photos ordered was 12. So his average last week was 12. Okay, right, and this week the customer ordered, and you can see here a list of stuff that the photographs that the customer ordered and how many ordered and whatever. And we have to then create the mean from this table and compare it to this number here to see if it's went up or down. Okay, you want to know if it's increased or decreased. All right, but one of the first problems you can see here, we don't have a solid number we can multiply, because this is the X column, this is your frequency column. Okay, so the X and F must be extended out to get the value. But you can see in this case, you can't multiply 26 by 1 to 10. So what we have to do, and you can see the question there, does the price increase seem to influence the number of prints ordered per customer? And it says explain your answer. So let me show you how to do that. The first thing you have to do when you get continuous data like this, before you do any calculations, is you have to find the midpoint. Okay, and you put the midpoint in there. Okay, and to get the midpoint, all you do is you take this 1 and 10, add them together, which gives you 11, and you divide it by 2. You take the 11 and 20, add it together, which gives you 31, and divide it by 2, and you do the same for everything, and you end up with something like this. Okay, so 5.5 is the middle part between 10 and 1, which is 11, and you can see the 5.5, and you do that all the way down. You create this midpoint, and what you're effectively doing is you're taking this continuous data here and changing it to discrete data. Now, discrete data is a solid number you can multiply by now. Okay, so you just extend it out like before we did in the last slide. You just add up that total number on your frequency column, and you create your little fraction. Right? You add up the top, add up the bottom, and you get 655, and the bottom number is 50. So you take 655, divide it by 50, and that gives you an average of 13.1. Now you see at the bottom there it says explain your answer. Now this is an area where people lose a lot of points in their maths, because they always leave that blank because they don't know what to say. Well, the very simple way to solve that is mention the difference or compare like for like. Okay, and that's how you explain your answer. If you think about it, you've done all the hard work. Now this could be worth 4 points, for example. You've done all that hard work and you don't explain your answer, and you lose 2 of them valuable points. All right, so in this case, what you do is you just say no. Your first instance is no. After the price increase, sales have gone up by 1.1 on average, And you see what I've done there? I've just mentioned the difference between last week's average and this week's average. And by doing that, I'm guaranteed to get the full marks. All right, so it doesn't matter whereabouts in your math paper that you get a question or what type of question it is. If it asks you to explain something, mention the difference or compare like for like, and you'll get the full points. Right, now you try it. Robbie played 20 football matches for his school team. The number of goals scored in each game are shown in the table. Calculate the mean number of goals scored per game. So pause the video, have a go, and see how you got on. So how did you do? All right, again, create your little fraction, okay? Extend it out so you add the top, add the bottom, then simply divide the top by the bottom, and you can see there that the average is 1.7. So if you got 1.7, absolutely fantastic, well done. Now, finding the mean and mode from a frequency table. The table shows the ages of an under 21 rugby squad, and we want to find, in this case, we want to find the median age. So you have to think about this one. It's a bit complicated, not too bad, but a bit complicated. It's just remembering how to do it. So what you do is you add the frequency column, and you can see if you add that column up, it comes to 23. Okay, now what you have to do with that 23 is you have to add 1, all right, to make that 24. And then you divide it by 2, and that gives you a median of 12. So the next thing you have to do is you have to find the 12th value down from the top of the frequency table. So you can see we go 5, 10, 11, and 12 is in here somewhere. Okay, so 12 will be down here. So you go to there, and then you simply go across, and you can see the median age is 20. And that's how you get the median. The main thing to remember is you have to add 1 to your frequency column, right? Divide it by 2, and then count down the values from the top. So that's how you do the median. And how mode? Well, the mode is fairly simple. Okay, you just go down the frequency column till you come to the number with the most frequent, because number 20 is seen. So you look for the highest value in the frequency column, which in this case is 9, and you can quickly see that 20 is the mode. Okay, and that's how you calculate the mode. The mode is 20. So, and frequency tables. I hope that helped, and thank you.